Hey there, ladies and gentlemen, boys and girls. Today, we're going to get right into it. We're going to do a video on how to calculate velocity given a position time graph. All right, so today we're going to be doing a little bit of math here. So pause for the groan. Okay, we're going to do math here, and we're going to talk about how that slope, and we can actually calculate that slope to calculate velocity. And remember, velocity is speed and direction. So today we're going to talk about how we calculate speed and direction, knowing that we already know that on a position time graph that the slope on this graph is going to indicate to us the speed. So we got to do that first. So before we even get started, I'm going to do some of the calculations, and I'll talk about the mathy stuff here. I need you guys to copy down this graph here. So I'm going to pause right here, and you pause the video. You copy that down. Okay. I'm assuming you finished there. All right. So let's talk a little bit about what we know here. We got two lines here. All right. Let's start here. Let's start with actually this idea right here. That's slope and speed. All right, it tells us speed. So if we know what the slope is, we know what the speed is. And so we need to create some sort of formula for us to calculate the speed of an object that made this graph here. So let's kind of do the math. Let's do kind of the big picture mathy stuff first. All right, so first thing we need to understand is about what is slope. Slope on a graph, right? It's rise over run. It's the change in the y-axis divided by the change in the x-axis. All right, so we know slope tells us speed, right? So in math class, slope is a change in the y-axis. That triangle is actually the Greek letter delta. It means change over the change in the x-axis. All right, which then we would calculate that as actually being. To do that, we need to get 2 points on the graph, on the line. To find the slope, you need 2 points. All right, so you would just pick, this one and this one, or this one and this one, or this one and this one. Just depends on which part of the line you're talking about. And then you have 2 coordinates, and then find the change in the y is y2, the second y, minus y1 divided by x2 minus x1. That's how we find slope in math class. All right? That's a kind of a generic term right there, right? Slope. So what I want to do, just trying to get that out of the way. All right? We know that slope is speed. All right? And it's actually what it is let's keep it there. Slope is speed and direction, right? Which is velocity. So in this case here, actually the slope on this kind of graph is to find velocity. It's a change in the y-axis over a change in the x-axis. But we don't have generic. We have units, actual things. So an x-axis here is time. So we use a change in time, because that's our x-axis. And change in, again, that triangle means delta or change in the y-axis, but this time it's position. So to find velocity, we have to find the change in the position divided by the change in the time. Right? So I can write this even kind of shorthand. Now, to make things extra complicated for you, all right? For time, we represent time with the lowercase t. Nice and easy. For position, to make things complicated, the letter we use to represent position is the letter x. All right? So it's actually a change in the position over the change in time. But just like we did up here, change in y is the second y minus the first y. Change in the x-axis is second x or x minus first x. We have to pick 2 points. We're going to do the change in position. So we're going to have what we call the second x, or the second position, or what we call the final position, minus that x representing its position, the start position, divided by the final time minus the starting time. Notice how it's final minus start, or what sometimes we call final minus initial, just like it's 2 minus 1 here. All right. Here is our formula. Now I drew it kind of really big and complicated here, just to make kind of show it all out there. So now let's apply this here. All right. So that's our big formula. All right. It's a big one. Let's show what this means. All right. We're going to calculate the velocity here. All right. So we're going to do this. I have this line here. I really have 2 parts to this line. So let's start with the kind of the things we already know. So I have this first part here. All right. Kind of this part in green. Right. And we know things just looking at it. It's very steep, which means that we know it's kind of fast. And we know that that's a positive slope. So we know it's going in the positive direction. All right. So just to know about the slope telling us the speed and direction, we know it's going fast and in the positive direction. While this one right here, we know it's not quite as steep, it's shallower. So we know it's going to be slower. And it's a negative slope, so we know it's going the negative direction. It goes in one direction fast and then turns around and goes slower in the other direction. The goal today is to actually give a number. How fast and how slow. Put some numbers to this. All right? And we'll do this we'll kind of do it 2 different ways, because we're going to break this down. We're going to do the red, we'll find out how slow it is and get a number. And we're going to find in the green, we're going to find out how fast it is. All right? So we're going to do 2 separate ones, because there's 2 different slopes, fast in the positive, slow in the negative. All right? And we're going to use this formula here. So let's do the green one first. Just like with slope, you need to find 2 points. I need to find 2 points on this line. If it's a straight line, any 2 points will work. I'm going to pick this one down here, because 0, 0 is so easy. We'll say this is my start point for my green, and I'll pick that one right there to be my final point for green. I got my 2 points. I got my final point and my starting point. All right, here we go. The velocity. It's going to be equal to we're just going to go straight to this one. The final position minus the starting position, final time, minus the starting time. So let's just plug in these numbers here. All right? Remember, the x being position in this point here. All right? So what is my final position? It is positive 6 meters. Minus my starting position, which is 0 meters. All right? Divided by my final time, because that's the final one. Final time is 3 seconds minus my starting time, which is 0 seconds. So I get positive 6 meters in 3 seconds, or a positive 3 meters per second. There's my units right there. Right, my units are right here, meters per second. I just added it there. This is my velocity. I have a speed, 3 meters per second, and I have a direction, positive direction. This together is my velocity. A velocity is a speed and a direction. So at this part right here, the green, it's going a velocity of 3 meters per second. And it's a straight line, which means it's constantly going 3 meters per second. Every second, it's going 3 meters. All right? So now let's try the red part. Let's see how that compares to the velocity of the red part. All right? Which we know is going slower, so we're assuming it's a negative. Notice, first of all, fast in a positive direction ended up with a positive number. I'm assuming I'm going to get a negative number here. All right? So let's do the same thing. Just setting it up. And as the more we do this, the more it's going to feel familiar. Just setting it up is always the hard part. All right, I got to pick 2 points, one to be my final and one to be my start, just for this red line, because that's the part I'm trying to find my speed. All right, I can pick any 2 points as long as it's a straight line. I'm going to pick, just to make my life easier, I'm not going to pick that same one. I'm going to pick this point right here. That's going to be my start. I'm going to pick this point right here. I'm going to make that my final. Really shouldn't matter what number or which one I use. All right? So, here we go. I start my final. So my final position, going all the way across here. That's at positive 4 meters. Minus my starting position. So I did 5.5. Should have picked an easier number, but oh well. My final time, 8 seconds. My starting time, 4 seconds. Positive 4 minus 5.5. It's negative 1.5 meters. Divided by 4 seconds. Oh, my mistake. I looked back at this for a second. I realized, here we go. It's at 3.5 seconds. Woo! That could have been bad. Which would change this to negative 2 meters in 4 seconds. My apologies. I was just looking at the wrong number. That'd be negative 0.5 meters per second. There's our unit for velocity. But remember, velocity is made up of 2 parts. Right? Speed speed and the direction. That makes up our velocity. All right, our speed and velocity there. Notice I said I thought it was going to be slower. Well, 0.5 is less than 3, and I said they were going to be in opposite directions. It's a negative slope. I ended up with a negative number because it's a negative slope. All right. Now, it seems kind of like a lot. There's a lot of numbers there and a lot of things. All right. Couple things to kind of keep in mind. All right. One, don't mess up your data points like I did a little bit here. All right. You got to pick. Here's our formula. You pick 2 points on that line. One is your final, one is your start. Here's my final, here's my start. Doesn't matter if it's a straight line. I could pick this one and this one. It doesn't matter. I plug in the parts I know into our formula. I'm going to end up with a speed and a direction, which we call velocity. All right, that's kind of a lot, and we're going to practice some more of this. All right, just using that position time graph, knowing about how fast and how far we're going. How much we change our position, and a certain amount of time gives us our speed and direction. All right, that's going to be it for all. This one's a little tough. Make sure you take this one down in your notebook. All right, we'll talk about this one more in class. Otherwise, thanks for watching. Good luck, and may the science be with you.